Hello everyone. Now we start our today's session. Before starting this session, first of all, I will give some of the instructions which is required. Okay, so first of all, my name is Sumit Kumar. I am PMRF Research Scholar at IITI Sandhanba. I am taking the course of Geotechnical Engineering too during this session, and in this session, I am interacting with you relating the concepts of Geotechnical Engineering too, in which we studied up to that the shear strength of soil, in which we studied direct shear test, that is the box test, fancier test, triaxial test, and some more tests also we have gone across. But primarily we have gone through these three tests and what are the main advantages, specifically in the triaxial test. What we are able to achieve is understood by us, and the some of the very good problems we have taken during the last class. And today also, as I have already said to you, that we are going to solve at least two problems, which are the very good problem. If you have gone through the problem which we have discussed during the last class, then you will feel very comfortable in solving this problem. And these are two of the best problems which I only kept for today because I think if you solve those problems which I have taught you during the last class, then you will feel very easy to solve this difficult problem as well. Okay, so some more instructions like the this video is recorded by me and this will be shared with you at the end and on the YouTube channel, and the content which I am going to take over here is also shared with you by the NPTEL team. Apart from that, one more instruction is like this session is going to run from 3 to 5, and this is the lecture for week 6. And if at a certain point of time, due to any network problem, if my call get disconnected, so please be remain in the meeting. I will rejoin. Otherwise, from the last five classes, this is not happens anytime. But due to any problem, if this takes place, so stay in a meeting. I will rejoin and continue the session from there on. And with this note, I will start the session. And today we are going to discuss some new concepts. So the I don't think the revision section is required in specifically which I am taking during the last few sessions. I first of all revise the last session, then I am starting with new content. But this time I feel you are more aware about those concepts because I have taken those classes in very detail. So I can start with the new content which I am going to discuss. First of all, I take the two of the problems which are based on the tri-Excel test. Afterward, we will start the concepts, and on the basis of those concepts, I also framed some of the very good problems. And specifically, those people who are watching in a YouTube, I will request you to see the entire video, and at least if you are not going through the video, you must go to the last section. Over there, I put some questions for you, so you can go with that, and you will find those questions very helpful. Okay. With this note, I will start the today's session. I'm sharing my presentation and starting the session. I think so. My screen is visible for everyone, so I will start from here only. This is the week 6 session in which we are going across, and during this session, I am going to take the content regarding the active earth pressure and passive earth pressure like things as well, through which you understand that what we have studied during the previous two sessions. Apart from that, we are also going to study the approaches like the stress path, as we have already understood what is the meaning of sigma 1, sigma 3, like when we apply the stress in the confining stress, and what is the what happens when we take those concepts during the second stage. So those things we will take into account during this session. So okay, I think so. My screen is visible for everyone. If at any point of time my screen is entire screen or browser window. Okay. So at any point of time, if any problem related to audio and video or presentation, you can ask me. And if no problem, then you should just stay in the meeting. So I will continue from here. Okay, so this is the week six lecture of Geotechnical Engineering 2. This course is taken by Professor D.N. Singh sir of IIT Bombay. So in this course, we have up to that time, up to this time, what we have learned. So the more or less what I said, that we have understood the shear strength. And shear strength is one of the basic concepts how we find the shear strength. What are the different tests with which we can conclude that this shear strength must have this soil in order to sustain the specific amount of load. So those concepts we have acquired and we have well understood like what is going to happen if the strength of soil fall below or above this parameter. And during the triaxial test, we have understood primarily the UU test, CU test, and CD test, which means in which we have understood that what type of soils, like when the clay soil is there, when the sandy soil is there, when the C5 soil is there, how we can able to find our parameters. So those concepts are very much clear for us. So today we are going to implement some more concepts. When we are talking about some more concepts is like we are talking about the stress path. But before going to that, I will want to take the two of the questions which I already said about during the last class that we are going to solve in this lecture. Afterward, I will take the content forward. Okay, so let's start. And first of all, this is the problem. This is the problem. The questions state that a conventional drain triaxial compression test uh, was conducted on a normally consolidated clay sample under an effective confining pressure of 200 kilopascal. The deviatric stress at failure was found to be 400 kilopascal. An identical specimen of same clay sample is isotropically consolidated to the confining pressure of 200 kilopascal and subjected to a standard undrained triaxial compression test if the deviatric stress at failure is 150 kilopascal. So find the value of pore water pressure developed up to 1 decimal places. Okay, so this is a very easy problem if you have gone across the concepts which I have taught, and specifically if you have gone with the problems which we have discussed during our last session. So I will solve this problem for you. Then we will go ahead with a new concept. So first of all, what are the things which has been given? Uh, I will write only, and you will see. So first of all, I already said the things how we have to read the question. So first of all, we have to see what is given. So it is given the test is drained triaxial compression test. Drain test means the valve is open and water is allowed to flow out and is conducted on normally consolidated soil. Soil is normally consolidated. Basically, we understood what is mean by normally consolidated, what is mean by over consolidated. So these things is also very much clear for you. And the soil is clay soil under consolidated clay soil under an effective confining pressure of 200 kilopascal. Effective confining pressure when we are talking about this means we have sigma 3 dash. I think so. This thing is very much clear when we are talking about the effective confining pressure. So it is sigma 3 dash. I will write this thing for you. Okay. So sigma 3 dash is 200 kilopascal. Now the deviating stress at failure was found to be 400 kilopascal. So you must need to understand the value of deviating stress at failure is 400 kilopascal. Hence, this value is nothing but sigma 1 minus sigma 1 dash minus sigma 3 dash or sigma 1 minus sigma 3. Anything you say, both things are same in a one way or other because it must you understood. Like if we write sigma 1 minus sigma 3, so that value has the same answer as well as sigma 1 dash minus sigma 3 dash. Now question arises why? Because when we talk about sigma 1 dash is nothing but sigma 1 minus 4 water pressure, and sigma 3 dash is nothing but sigma 3 minus 4 water pressure. If we subtract direct value of sigma 3 from sigma 1, we got the same value as if we subtract the value of sigma 3 dash from sigma 1 dash, because the poor water pressure get cancelled in any cases. Now, when we go ahead in this question, the next part in this question is saying that an identical sample, the sample which each to I have today, the same type of sample is taken and isotropically consolidated to the confining pressure of 200 kilopascal. But there is a twist and turn is also there. And what is the earlier we are doing the drain test, this time we are doing the undrained triaxial compression test. So afterward, this value of sigma, the test is undrained, hence pore water must develop, and so this value is sigma 3, and this value is like 200 kilopascal. Okay, and subjected to the if the deviatic stress at failure is 150 kilopascal, then the pore water develop pressure develop in these sections. What this is saying. So over here sigma 1 minus sigma 3, and this is equivalent to sigma 1 dash minus sigma 3 dash as well for this case. But we are taking the total stress parameter, so we go with the total stress parameter only during this time. So this value is 150 kilopascal. Now you must know that I have said you that there is a relation between sigma 1 and sigma 3. So sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. You must be aware about this relation. Sigma 1 is equal to sigma 3. I will write those relation. Sigma 1 equal to sigma 3 tan square 45 plus 5 by 2, because this relation is used to solve this problem, plus 2c tan 45 plus 5 by 2, 2c tan 45 plus 5 by 2. Now see, because I am solving this for you, because I already have kept the solution, but if I solve by my hand over here, then you will understood more better way. That's why I am trying to solve this in this manner. Okay, so you see in the first case we already know the value of sigma 3 dash, sigma 1 minus sigma 3 dash, so sigma 1 dash is also known, that is 600. So when we use the relation given above, and the soil is already given clay soil, hence the value of C must be there, but phi can be considered 0. From that we are able to find the interrelation, but this is not the case. We are not interested in this. But when we solve this problem, we must know that sigma 1 dash is equal to sigma 3 dash tan square 45 plus 5 by 2 plus 2c dash tan 45 plus 5 dash by 2. This interrelations also work in a similar manner. When we use that interrelation and we are going to solve, we use the same relation to solve the problem, as you can see from the solution. Now I show the solution for you, because I am very much confident that you are aware about what I am wanting to convey. So for in the first specimen, sigma 3 is given as 200 kilopascal, and in the second specimen, sigma, in the first specimen only deviatic stress is 400, so the sigma 1 dash is 600 kilopascal, and from that we are able to find the value of sigma 3 and sigma 1, and on the basis of that we already know from the question, the pore water pressure, when it gets subtracted from the total stress parameter when the test is untrained in the second specimen, the parameter given is total stress parameter irrespective of effective stress parameter, hence the sigma 1 dash and sigma 3 dash need to be calculated, which we are studying as sigma 1 dash and sigma 3 dash, same commodity is stated over here as sigma 1 bar and sigma 3 bar, and when we solve the problem accordingly, we are able to get these two conditions for the second specimen. And when we use the interrelation which I have written over there for you, you are able to find the value of phi from here, and when the value of phi is known, we are able to calculate the value of pool water pressure for this specimen, and that is the problem which is we need to solve during this. Okay, so I think so all points are clear. You must go ahead to solve this problem with your hand in your notebook. Then you will get the far better idea. And I think so the concepts which I discussed during in this slide only is more enough to solve this problem, but the solution is also provided, and I also discussed that solution for you. Okay. Now I will go ahead. So going ahead, you can see that there is another problem also. I have already have said that we are taking two problems during this class. So this is the problem related to the same concept of the triaxial test only, but over here we are going to calculate the in a very first or second class we have calculated the value of sigma and tau. So sigma 1 plus sigma 3 by 2, and again like sigma 1 minus sigma 3 by 2, the interrelation to find the value of normal stress and shear stress. So those interrelation could be used over here in order to calculate the values what for this problem. So first of all, I read the problem, then we will go ahead with the solution. So the total horizontal and vertical stress at point X in a saturated sandy medium is 170 kilopascal and 300 kilopascal respectively, and the static pore water pressure is 30 kilopascal. So the static pore water pressure is mentioned. This is the first time we are coming across like these terms. So the static pore water pressure means this pore water pressure is they are all across. Similarly, at failure, when the failure takes place, the excess pore water pressure measured is 94.5 kilopascal. So first of all, we have the habit to underline the important things. So the mention is the total horizontal and vertical stresses at point X, each 170 and 300 kilopascal. Okay, and the static pore water pressure each 30 kilopascal. So every important point you must underline in your answer book, in your question book or anywhere, with either if the you are solving with the help of in a book, you can underline with the help of pencil. Okay, so at failure the excess pore water pressure is measured to be 94.5 kilopascal, and the shear stress on the vertical and horizontal planes passing through the x is 0. So the effective cohesion is also mentioned as 0. So we'll underline those facts as well. And afterward, the effective angle of internal friction is given at 36 degrees. So the question is to find the shear strength. So, first of all, we calculate the sigma n value, that is sigma 1 plus sigma 3, 300 plus 170 by 2. The horizontal and vertical direction stress is given. Plus 300 minus 170 by 2 into cos alpha, and the phi is given at 36 degree. So alpha is 45 plus 5 by 2. Okay, this one. And from this interrelation we are able to calculate the value of sigma n. From this interrelation we are able to calculate the value of sigma n, and when sigma n is calculated we are going to calculate the sigma 1 dash by finding sigma 1 minus u, and with this we are able to calculate the value of sigma 1 dash as 72 0.29 kilopascal, and from this we already know tau equal to c plus sigma n dash tan phi. So using those interrelation we are able to calculate the value of shear strength for us. Okay, so now we will move ahead with a new concepts which we are talking about from very early. So what are those concepts we must need to go with? So first of all, we understood the what we mean by stress path, and I have also kept one or two problems from the stress part. Afterward, we will have question from the active and passive earth pressure. So we will go across one by one with all those problems, and with that, with those problems, you must feel that these questions and solutions are not very difficult in a real sense. Okay, so first of all, unveiling the stress path in a geotechnical engineering. So, first of all, when we come to this parts, we will explore the concepts of total stress path, effective stress path, and what is meant by effective stress path. That is nothing but total stress path minus pore water pressure. So, those terms we come across during our study of the stress path. And stress path is the curve between P and Q, and where P, what is the value of P, what is the value of Q is one of the factors. So over there the P is sigma 1 plus sigma 3 by 2, and Q is sigma 1 minus sigma 3 by 2. The P value is drawn at the x axis while the Q value is drawn at the y axis. So those are the terms you must need to be aware about while solving the problem related to that, and what is the significance of studying these each also need to be understood. So these stress paths play a very important role in analyzing the soil behavior, and the very crucial for the designers as well. And as well as apart from that, the consultants who are working in the field of geotechnical designing, so those persons must need to be aware about these facts. Okay, so we have already studied the triaxial test. We have understood the concepts of triaxial test. Over there, first of all, in a confining stage, we apply the value of sigma 3. Afterward, as we move ahead, we apply the deviatic stress, and up to failure. At failure, we are able to find the value of deviatic stress, and on the basis of that, we are able to calculate the value of sigma 1. When the sigma 1 and sigma 3 with the help of that, we are able to draw the Mohr envelope. So that concept is there. But now with the value of sigma 1 and sigma 3, and sigma 1 dash and sigma 3 dash, we are able to construct the total stress path and effective stress path respectively. When I am saying respectively, when we draw the total stress path, in that case, we draw the stress path with the total stresses which is coming across, and when we are drawing the effective stress path, we consider the total stress minus pore water pressure like the effective parameter for drawing the stress path. And when we do the different test as already mentioned, if the we consider the effective path, so the value of effective parameter will be same, but the stress parameter like C and phi is not same for the total stresses and the effective stresses. And these things is very well understood by you. So the triaxial testing, first of all, a overview. There is no need of overview because you already understood, and I have explained those terms for you as well. Okay, so the two types of stress path is there, specifically two types only, not the third type. But this I just written for you to understood the difference between the total stress path and effective stress path. So the total stress path is a one thing, effective stress path is second, and the third one written as total stress path minus static pore water pressure. And this total stress path minus static pore water pressure is the effective stress path in a way. Okay, so the geotechnical transformations also takes place during our study. So what do we mean by the geotechnical transformation? The transformation of shear test result, the transformation of shear test result uh, from tau sigma to the PQ is basically our concern during this drawing of the PQ curve. So you must be aware about the fact that why we are doing these things. Is there any significance of that? Is there any application of those things which we are doing right now? So those things need to be understood and need to be stated. Okay, so first of all, there is some interrelation that develops like the value of K, Kp. and the interrelation specifically which is in use is the value of and what is the value of P and what is the value of Q, because if we understood the value of P and Q, then we are able to find the value of then we are able to find the value of the some other parameters like when we are talking about the other parameters like what do we mean by what do we mean by the PQ curve? Because when we draw the stress path, either the total or effective, we must need to understood the terms as well as the fact that why we are doing so. Okay. Okay. I think so. Audio and video is clear, but there is a interest over here. Give me a minute. Okay. So okay, no problem. So we will go ahead from here. So afterward, the characteristics of the total stress path and definition of total stress path becomes somewhat important. So what is the importance of that we must need to be aware about. So when we talking about the importance of the total stress path and similarly effective stress path, so what are the factors which govern those things need to be stated. So the first of all, the characterization of total stress path, defining the characteristics of total stress path is like it always inclined at 45 degree. When we talk about the impact condition, how the total stress path changes under the different conditions. When we talk about the conditions, so what are the conditions we are talking about? The first of all, first condition is the hydrostatic condition. When we talk about the hydrostatic condition, what do we mean by hydrostatic condition? Hydrostatic condition is like the when we study specifically the hydrostatic condition when the stress is applied equally from all the directions. This like in a 2D, if I draw the hydrostatic condition, this is the hydrostatic condition. The stress acting from all the faces are similar. All the faces are similar. Is the example of hydrostatic condition. This is the one of the hydrostatic condition. This one is also said to be hydrostatic condition. But when we keep any soil material inside, when we consider any soil material inside, the pressure act hydrostatic in nature in a similar manner as I am drawing over here. There is a little mistake, so I will erase it and draw it again. Okay. So these both cases are the hydrostatic cases which I am drawing over here. So this need to be understood what when we are talking about different conditions. So these are the representation of hydrostatic condition. The second condition is the back pressure and third is the standing water table. When we talk about the standing water table, when we talk about the standing water table, this is the pressure which is applied due to water table. Basically, if you suppose the over any places over any surfaces during a flood, the water get stand over there. So this pressure due to standing water table is sometime also act as surcharge. Sometime also act as surcharge. Sometime act as surcharge. Okay. I think so. Yeah, the things are clear up to this. Okay. So now the effective stress path. Over there we have studied about the total stress path. Now we are talking about the effective stress path. So when we talk about the effective stress path, the nonlinear behavior is they are exploring the nonlinear behavior of effective stress path under the undense shearing condition, and as well as dense condition. We also should go about that. Now the when we interrelate those things with the shear failure. So what we want to convey that we have understanding the stress path variation, like the variation of stresses on a PQ curve. But the failures also takes place, and when the failure takes place, when we are drawing the stress path, we must need to be studied. Okay, so and we have earlier we have stated the three factors. First of all is the total stress path, second is the effective stress path, and third is the total stress path minus static pore water pressure. When we talk about the total stress path minus static pore water pressure, this is nothing but the effective stress path only. But these things is taken into account to explain those terms in a two different aspects. So the you get the clear idea about the fact that the effective stress path. What do we mean by effective stress path? Because sometimes it has been seen that the students gets confused in an effective stress path. So that's why to state those things to you, this two terms are stated over there. So when we talk about the effective stress path, significance of TSSP or effective stress path, so its importance in understanding the static pore pressure variations, visualization of pore pressure influences, and the shifting of total stress path to the effective stress path, and interpreting the difference between the static pore pressure. So those terms, because in the most of the time when we talk about the pore water pressure remains static at a specific location. It doesn't vary very frequently. At some point of time, at a different point of time, it may be different for some aspect, but when we talk about the static pore water pressure, the pore water pressure remain constant at a specific cross section in a soil on a specific depth as well. Okay, so no, now we will move ahead with the practical applications. So, what are the practical applications we could go with? So, the design implication, how the stress path impact the design decision analysis, because we are studying from the first day only. When we talking about the shear strength, we have understood its significance, its applications, and what are the benefits we are getting from that with the help of the knowledge of the shear strength, how we can help. So similarly, those factors are applicable for this case as well. So the when we talk about the design implication, how stress path impact the design decision analysis. Another thing is the in a real world scenario, the stress path assists the consultants, the person who are working in a field as a geotechnical engineer, as a site engineer. We need it provide a path to frame the work over there, or what type of stresses are coming. Those things he is able to understand. So now I recap this section, and afterward we will go ahead. Over there, I will show a different example of stress path, and with the help of some diagrams, so you will get the better idea of these facts. So understanding the stress path is a key asset for the geotechnical engineers and designers. By comprehensive intensities of the total stress path, effective stress path, the different professional can um, interpret the test result and predict the soil behavior. Because whenever we are studying any things like this, we are main concerned about understanding the fact about what is going along the what is going into the soil section. Because if that is not the fact, so it's become very difficult for it's become very difficult for anyone to understand the things like why we are performing. So with the help of that, sorry, we are able to state the behavior of soil. Now I will go to the next section, in which we are talking about unveiling the stress path in the geotechnical engineering. This is not only the only section where we are studying this. In the subsequent section also we are basically unveiling the stress path in the geotechnical engineering only, but these sections are divided into section by section, because when I share this presentation with you, you can go for one sections, afterward you go for second sections, in between you can take a break. So that section seems to be bifurcated, and the content is very elaborated, so you are easily able to understood and easily able to read those sections. That's why it has been divided into parts by parts. Okay, so I will start with the stress path. So stress path is a curve or a straight line which is the locus of the series of stress points depicting the changes in the stress in a test specimen or in a soil element in situ during the loading and unloading engineered as in the triaxial test in the former case caused by the forces of nature. An elementary way to monitor the stress changes is by showing the Mohr stress circle at the different stages of loading, unloading, but this may come broach as well as confusing when a number of circles are shown in a same diagram. Exactly. You must understood like we in a triaxial test we perform the triaxial test we apply the value of sigma 3 afterward we change when we apply the value of sigma 3 after that we change the sections when I am talking about uh, change the sections. Okay, sorry, the slide get changed. Okay. So when I talk about the things get changed, so when I am saying this, what the is mean by this statement? The things get changed like when we apply the value of sigma 3, we get some deviating stress. When we apply the value of sigma 3 1, we get some another sigma 1 value. After that, we apply the sigma 3 2, we get another sigma 2, 2 value. And on the basis of that, we draw the Mohr circle of the different radius. Afterward, we draw a common tangent, but that sometimes seems to be confusing. So the geotechnical investigators try to find some other way to understand the soil behavior. So they find the stress path concept. In a stress path concepts, they try to find the value of stresses like on a x and y axis. Okay, I will show you one things with the help of one. I will take one slides over here and I will draw some points so you can understood very easily those terms. Okay, so I will take a pen. So in a PQ curve, what we are going to do, you must need to be understand what we are basic things we are trying to do. So first of all, we already know the value of Mohr circle when we are talking about like 1 minute. Give me a minute. Sometimes this thing takes time, but this give better idea. Earlier we know like we are drawing like this. In this manner we are drawing the value of we are drawing the different Mohr circles and afterward we draw a common tangent passing through this point and this is the value of C. This is the value of uh, 5. Okay, I think so this thing is very much clear. Earlier we have did this only. This is sigma 3. This is sigma 3 dash and this is sigma 3 double dash. Similarly, this point. Okay. Similarly, this is sigma 1 triple dash double dash. This is sigma 1 dash. With the help of that, we are drawing the Mohr circle. Now, what the change come when we talk about the effective stress part? So over there, this is the basically the value of tau sigma graph. Now the change which came across in our thinking is like now we are drawing the stress path like this, and in the at this the value is sigma 1 minus sigma 3 upon sigma 1 minus sigma 3 upon 2, and on this the value of sigma 1 plus sigma 3 by 2. Okay, so with the help of that, we draw a graph and we find the different points on this graph, and that is the points which we join. We are able to find the stress path. So these things we are trying to do during this section. So I think so. My points will be more or less clear to you. So I will go ahead with this in our discussion. So now the what are the things takes place? Specifically when we draw the Mohr circle with the same sigma 3, we get the value of sigma 1, and when we draw the top of most point of those circles, we are able to find the stress path, and this stress path is drawn between two things P and Q, and what is the value of Q and what is the value of P is very much understood by you. This is sigma 1 minus sigma 3 by 2, and this P is sigma 1 plus sigma, this is sigma 1 plus sigma 3 upon 2. I think so this thing is very much clear for everyone. Okay, so what are the things and who have stated these things? Those things, those background you must need to be understood. So first of all, I will state that, and afterward we will go ahead. So, the Lamy and Whiteman in 1969 have suggested the locus of the point representing the maximum shear stress acting on a soil at different stages by treated as a stress path which can be drawn study in the place corresponding to the Mohr circle, and that diagram is shown over here. And with this picture you could understood like we are able to find the behavior of soil as well in the one way or the other. So that is the basic things we are interested in. Okay. So as I already stated, the what is the coordinates and how we understood those coordinates. So those things need to be understood and things need to be clear. So over here the P and Q are the 2 points. P is the sigma 1 minus sigma 3 by 2, while Q is the sigma 1 minus sigma 3 by 2. I have stated at the two occasions. First of all, in a slide, I have drawn those things for you, and afterward, in the previous section as well, I have stated, and that things only written over here for your reference. When we talk about the sigma in a term of sigma 1 and sigma 3, similarly, we talk in the term of the horizontal and vertical principal stresses as well. So, if we consider it as the horizontal and vertical principal stresses, then also we can write as sigma v minus sigma h by 2 and p equal to sigma v plus sigma h by 2. So these awareness to be have for the engineers who are working in a field in order to solve the real problems they encountered with day-to-day in a day-to-day section. So these things need to be understood by everyone. Okay. Now, the effect when we talk about the effective stress part, the value of P and Q respectively change to P dash and Q dash, and P dash over there it becomes sigma 1 bar plus sigma 3 bar by 2, or sigma 1 dash plus sigma 3 dash by 2. Similarly, the value of Q is changed to Q dash as sigma 1 dash minus sigma 3 dash by 2, or sigma 1 bar minus sigma 3 by 2. And these things is very much clear, and I don't need to explain these things because I have taken this into various forms during the teaching the triaxial test. So this is a very basic. Now the stress path is the total stress less static pore water pressure, basically TSSP concepts. Over there, the static pore water pressure we subtract, so the value becomes sigma 1 plus sigma 3 by 2 minus u. And similarly, the second value becomes sigma 1 minus sigma 3 by 2 only. Now, there might be a question in your mind earlier also, I think so, some point of time you get confused, like sigma 1, how the sigma 1 minus sigma 3 by 2 and sigma 1 minus sigma 1 dash minus sigma 3 by dash by 2 is same. So I will state these things because if any confusion is there, so you will get very clarity on this terms. I think so. Audio and video is clear. If any problem at any point of time, you can state. I will try to rectify the problem. Okay. So now I am trying to explain the why sigma 1 minus sigma 3 is equal to sigma 1 dash minus sigma 3. I have stated earlier as well in a statement, but I haven't written any time. So I will try to write these things so you never confuse again, because most of all you understood, but anyone have any issue, I don't want to anyone have any issue regarding that. So sigma 1 dash is nothing but sigma 1 dash is nothing but sigma 1 minus u, sigma 1 minus u minus sigma 3 minus u. So that is equal to this u, and this u get subtracted, and this is nothing but sigma 1 minus sigma 3. I think so. This thing is very much clear. I don't need there is a further explanation needed on this concept, because we these are very basic things. I think you already understood, but for a reference, I try to draw it so you will easily get the idea if any one of you have any ever have confusion regarding this. Because sometimes see some students are confused in this small thing as well. So I don't want to keep any confusion in your mind on this topic. Okay. Now I will go ahead. So over there, the previous statements I have stated the different values. Now I'll try to explore those things for you. So first of all, you have understood those terms that what is going to taking place. So you over there U0 is 0 in a conventional triaxial test, and coincide this test case as well. But if the back pressure is used in the test, the back pressure is like the pressure is applied for the pressure is back pressure is applied with the help of back pressure is applied due to might be some soils would be there, or due with the water at that place. So how it act, how it gets changed, how stress path get valid. So for in those cases, for in situ elements, the static pore water pressure depends upon the level of the groundwater table. So slope of stress path line as delta Q by delta QP, and delta Q is nothing but Q final minus Q initial, basically Q not is nothing but the initial condition. Similarly, the delta P is the P final minus pore water pressure at final stage minus pore water pressure at initial stage, and with the help of that we are able to find the slope. And similarly we already know that the shear strength is the value of cohesion plus sigma tan phi. Any new visitor join, please mute yourself, otherwise it will be little bit problem for the other people in the meeting. Okay. So the value of CST is tau equal to C plus sigma tan phi as earlier. Now the Mohr Furor envelope also modified in a similar manner for the pore water pressure. We already know those facts, and how this vary, how the key lines changes, and those things is very much clear. And I don't think those things need to be taken over here. Similarly for the over consolidated clay as well. But I will take this section. So in this section, you see the value of sigma 3 is applied. The sigma 3 is the stage of the confining stage. Afterward, the sigma 1 is applied. The sigma 1 is the value to which we applied. Basically, the deviating stage is applied, and on the basis of that, we are able to find the value of sigma 1. And with the help of that, we are able to draw the Mohr circle, and on the basis of that only we are able to draw the stress path in which the value on the x-axis is the value of sigma 1 plus sigma 3 by 2. Similarly, the value on the y-axis is sigma 1 minus sigma 3 by 2. So, in a similar manner, we go ahead with our study with our sections. So, over here, I will take a small break of 5 minutes, and afterward we will go ahead with our discussions. So we will take the 5 minute break over here, and afterward I will start. Welcome back. We'll start the resume our session from here. Okay. I think audio and video is clear. If at any point of time anyone have problem with audio and video, they can write in the chat box or can state over here as well. Okay. So first of all, we are talking about we will take the problem from this concept, so we will understand those things in a more better way. But first of all, I will take the drain test. So in a drain test, the figure which is coming below shows a typical stress path. Point A correspond to the stress condition with only the confining pressure like the sigma 1, sigma 3 is same and nothing more takes place over there, and the value of tau H0. And the point F represents the failures and the stress path for the effective stress, total stress, and the total stress less static pore water pressure is shown separately in this figure coming below. So over here you can see the effective stress part, total stress part, and TSSP like the total stress. minus the static pore water pressure. All the three cases is represented, and from this graph you easily get the idea that TSP minus ESP is nothing but the pore water pressure. The difference of pore water pressure create the changes between those two terms. So now for the in a similar manner, if we see the for the consolidated undrained test on a normally consolidated on a normally consolidated clay, the figure below shows the typical stress path. Over here you can see the ESP, TSSP and the TSP. The stress path for the consolidated undrained on a normally consolidated clay, you will able to find the value of the difference of those two value will give you the pore water pressure. Okay, so we will go ahead and similarly for the consolidated undrained test as well, the diagram will be drawn in a similar manner. Now, take a special note. The note is like the TSSP to the right of ESP indicate the positive axis for water pressure, while the TSSP left to the ESP indicate the negative axis for water pressure. When we talk about the positive pore water pressure and the negative pore water pressure, so we need to clarify. We need to understand what do we mean by positive and negative pore water pressure. So if the pore water pressure is positive, the value of effective stress will reduce. But in the same manner, if the pore water pressure is negative, the value of effective stress can increase irrespective of decreasing. So the both the cases, both the instances will give us the different result for us, and that will lead to the different situations. So we need to aspects, we need to understand those terms in order to convey our statement in a true manner. Like if the pore water pressure is positive, pore water pressure is negative, the change in the effective stress path will be effective. Effective stress path one times will act in a positive manner, in other time it will act in a negative manner. So these things need to be very much clear in your mind. Okay, I will go ahead with this question. Okay, so this is a very good and very good problem. So I will solve this for you over here. So you will get the very good idea of the questions like this and how we are able to solve the problem. So first of all, the question is stating the stress path equation for the triaxial test upon the application of debritic stress is given as Q equal to 10 root 3 plus 0.5 P, and the respective value of cohesion and angle of internal friction is asked. So for this, what you do? So first of all, you can perform. The solution is already there, but I will state some of the things so you will easily solve the problem. Because sometimes if you are not about aware about the fact, you might be sometimes not able to solve the problem. So I will write those things for you. So we already know. Okay, I will take a pen. The value of P is the value of P is sigma 1 plus sigma 3 by 2, and value of Q is sigma 1 minus sigma 3 by 2. This awareness you must have, sigma 1 minus sigma 3 upon 2. Now, when we put the value of Q as sigma 1 minus sigma 3 by 2, sigma 1 minus sigma 3 upon 2 equal to 10 root 3 plus 0.5, on the place of P we will write sigma 1 plus sigma 3 by 2. Okay. So we will now we will solve, and on solving what relation we are able to find, we will take suppose okay, I will solve as well. So how we can solve? I will solve like sigma one. When we take the sigma 1 by 2 as common, sigma 1 by 2 common, 1 minus 0.5 equal to, we have taken the value of sigma 1 as common, so 1 minus 0.5, and we must aware about sigma 1 equal to sigma 3 times 45 plus 5 by 2 plus 2 c tan 45 by 2, we are aware about. So we will take the sigma 3 common over there. Sigma 3, so 1 by 4. Sigma 3, 1 by 2 and 0.5, 1 by 4, mm, plus 1 by 2, plus 10 root 3. So basic thing I want to, what I want to convey is like sigma 1 equal to sigma 3 times for 45 plus 5 by 2 plus 2 c tan 45 plus 5 by 2. So you have to frame this relation in this term. Sigma 1 equal to sigma 3 tan square 45 plus 5 by 2 plus 2 c tan 45 plus 5 by 2. 2 c tan 45 plus 5 by 2. Okay. Up to this, the things are clear. So on framing this relation, you find some constant over here. So this constant is become equal to 2 6 10 45 plus 5 by 2. And then first of all, you solve these things at 10 square 45 plus 5 by 2, you will get the value of 5. On using this value of phi in this relation for this constant, you are able to find the value of cohesion. So the value of C and phi is known to you. So this thing when you do, you are able to state the solution for this problem. Okay, so I will go ahead by point. So in this problem, the first of all, I already stated the P sigma 1 plus sigma 3 by 2 and Q is sigma 1 minus sigma 3 by 2. And on taking the relation and interpreting the result, we are able to find the solution. But with this solution, you might be confused. So that's why I have written this for you. So you are easily able to solve the problems in a good manner. At the end, you will get this solution, the value of C as 20 and value of phi as 30 in a respective way. Okay, so I will move ahead with a new concepts from here. So I think so this thing is very much clear, and now we will move into the understanding the soil and the stress path and their applications. So the application is one of the important parameter. We are very keen about that fact. So we must have the knowledge of applications, because anything we have studying, because it must have some applications. Okay. Now we will try to find understand the parameters for what we have studied about in these sections and what we are wanting to get out of that. So first of all, you must be aware about this fact, like The slide doesn't get changed. Sorry. Okay, now it's okay. So you can see over here, the soil stress path play a very important role in the geotechnical engineering designs, like the total stress path, effective stress path, and the pore water pressure. So the pore water pressure and the material behavior, when we are talking about the pore water pressure, differences at failure define the different soil behavior. Positive pore water pressure correspond to the normally concentrated soil. Similarly, the negative pore water pressure characterizes the over concentrated soil. So this aware must need to be in our mind, and this fact must be clear. So we are able to state the things in a more or less a better manner when we talk about the applications. So basically when we talk about the stress path, why we are studying the stress path, the one and only reason to understand the stress path in order to state the behavior of soil. If we are not able to state the behavior of soil, there is no need to understand the one different things, because we already know the sigma 1 sigma 3 value. With the help of that we already draw the Mohr envelope, but over here we want to understand the aspects regarding the fact that with the help of this aspect, with the help of drawing the stress path, we can when we join the topmost point of the Mohr circle, we are able to differentiate the different type of soil, the different types of behavior of soil, like in the over concentrated and the normal concentrated soil. So we have studied the triaxial test specifically in two classes, in which we have discussed the detail about the different type of triaxial test, and in a stress path analysis as well we have implementing those concepts only, those aspects, those parameters. With the help of that we have stating our interrelation. So the stress path help in determining the A parameter. We have understood the Skempton parameter like A and B. So the stress path also help in that aspect as well, related to the pore water pressure and the material property. And by plotting A parameter, the variation, we gain the insights into the soil behavior under the different stress condition. Now the isotropic compression and the stress path. So in isotropic compression and stress path translate vertically due to the uniform stress changes. The total stress path, effective stress path is isotropically compression helps to analyze the stress strain relationship. Moving ahead, when we talk about the total stress path in the construction activity, the soil stress path are crucial for understanding the construction effect of soil masses. As already discussed, it helps the consultant engineers, the site engineers, and the field engineers in understanding the behavior. And the load increases vertical stresses sigma b, resulting in the positive delta sigma b, and unloading decreases the vertical stresses leading to the negative pore pressure. So when we talk about utilizing the soil stress path for the stability analysis, the stress path are the pivotal in stability analysis. The Skempton equation define the pore water pressure using the A and B. And how we are defining? We have defined the B parameter as change in pore water pressure by changing delta sigma 3. Basically, in the confining stage, what is the change in the pore water pressure? And similarly, when we talk about A bar is the AB, and A bar is the change in the pore water pressure by the change in the deviatoric stress. And when we combine those two terms, we are able to get a relation. With the help of that, we are able to state the total change in the pore water pressure. So the stress path help in identifying the limits of loading before the soil failure. And the basic aspects we are studying is to get the value of the strength of soil, so that we will apply the stress up to that limit only, before which the soil doesn't fail. Because if we apply more than that load, the soil will fail, and hence the problem will arise for us. Okay, so we will go ahead, and when we go ahead we will see that the implementation for the design and construction. When we talk about the implementation of design and construction, the understanding the stress path is essential for the safe design and construction, because the stress path is one of the most important aspects, because we have studied again and again. With the help of state path we state the properties, we can state how the soil behaves. The relationship between the loading and the soil response is also crucial for a successful project, because if we doesn't interrelate the loading and soil response, so we are not able to state the how the soil is going to behave. Okay, so the practical, when we talk about the practical example, the this implementation must take place at some place, because when we are talking about, it will help the site engineer, it will help the construction practitioners. So how it will help, that must also we need to state. So the real world example so is the importance of stress path, the load bearing capacity of the rail tracks, and the tall buildings depend on the soil behavior and the stress path. The proper understanding ensures the efficient and secure infrastructure development. When we recap this section, the soil stress path provide a vital insight into the soil behavior and the stability. It mastering the stress path analyze enhances the geotechnical engineering design, and continual learning and the application of stress path concepts are crucial for the successful projects. By developing into the soil stress path and their implementation, you can gain the valuable knowledge to enhance your work in the geotechnical engineering. And remember one more thing, to understanding the stress path, like the language of, it is a language of soil. It state that how soil is going to work and help us in the design structure and the test in time. So those aspects we will able to get with this knowledge. Now, so we are going to decode the soil behavior through the stress path, because from initial only, first of all we enable the soil behavior of the stress path. Now we want to decode this things with the help of stress path. So the specifically intercepting stress path, the soil stress path in guiding, it is basically one of the guiding principle, because when we talk about the every aspects in any sections we go, there must be a benchmark. Basically benchmark is the guiding principle for us in going in that direction only, because if in any cases, in any experiments we are going to perform, there is a specific specification is provided, like we have to follow this section only. So the stress path work as a benchmark, as a guidelines through which the practitioners go to find the to state the behavior of soil in different conditions, like in the normally consolidated soil, over consolidated soil. When the over consolidated ratio vary, because when we talk over consolidated soil, we say OCR value is greater than 1, and then the question arises, what is OCR? So that is clear to you, but I again state you, the soil in the stress on the soil in the past by stress on the soil in present. So when we draw the graph for the OCR, you can see that the OCR value could be 1.5 and could be 5. So the soil in both the condition will not behave in a similar manner. So in a similar case, the stress path, so the represent us a guideline which we need to go with in order to state our result. Now, the different stress path we already aware about, the total stress path, effective stress path, and the total stress path minus static pore water pressure, that is KSSP. And the pore pressure and the soil behavior, when we talk about the pore pressures role in defining the soil characteristics, the positive pore pressure indicates a normally concentrated soil, and negative pore water pressure determine the over concentrated soil. This statement already came in our study. Now when we talk about the implementation, when we talk about the implementation, so the implementation is one of the aspects which we need to be aware about. Basically, anything we study, we talk about the implementation. So how we, with the help of stress path, we state the behavior. That is one of the very important aspects. Okay. Now, when we talk about the triaxial testing and A parameter we are aware about, we have talked about as well during this class as well as during the earlier classes. Now, the isotropic compression and the stress path. In isotropic compression, stress path shift uniformly. The total stress path and effective stress path in the isotropic compression elucidate the stress strain correlations. Now, the soil stress path in construction during the soil stress path is one of the important factor, and the loading intensities like the delta sigma v the positive delta sigma v value and unloading reduces the vertical stresses resulting in the negative pore water pressure. And we have talked about the positive and negative pore water pressure because the positive pore water pressure lead to the shifting of the effective stress path in a leftward direction and vice versa for the negative pore water pressure, because if the pore water pressure is negative, the effective stress path become more, and similarly if the effective pore water pressure is negative, the effective stress path will reduces. So the both are the cases. And when we talk about the positive pore water pressure, the soil is normally consolidated. Similarly, if the pore water pressure is negative, the soil is over consolidated. So those aspects are very much clear in our mind. With this, we will go to the active and passive earth pressure. With this, we are going to understand the active and passive earth pressure. So first of all, we recap these sections, and then we will go ahead with the active and passive earth pressure. So the soil stress path. When we talk about the soil stress path, it is a window in the soil behavior and stability, and mastery of the stress path analysis enhances the geotechnical engineering design. Obviously, this is the main aspect, and continual learning of the practical application of the stress path concepts enhance the project speed. And by delivering into the intrinsic of the soil stress path, we have empowered ourselves to profound knowledge to enhance the geotechnical engineering endeavor. And one thing must need to be remembered, that the stress path enables us to craft a structure that stand resolute against the test of time. Now, soil behavior, again we are talking about, we will go to directly go to the we will go for the sections known as the active and passive earth pressure, because we are running something out of time. So these things already studied again and again, so I don't want to repeat the same things for the several times. So I will go for those sections in which we have studied the, and if the time permit, we will go for these sections again. Otherwise, I will provide the presentation. You will go with everything written in detail. So no problem with that. So first of all, we will study the value of active and passive earth pressure. Okay, so plastic equilibrium is also one of the concepts which I want to take. Okay, so I will start from here, and we will go in little faster manner to complete the remaining section. Okay. So the when we talk about the recap of the shear strength and introduction of plastic equilibrium, we have very much clear idea about that. We have understand the value of shear strength. We have understand the value of the different sections over there. Now the application of plastic equilibrium. When we talk about the plastic equilibrium, what is the application? It gives the idea about the practical application of the plastic equilibrium, because when we talk about the soil, it acts in a plastic manner. It is not elastic. It is not like things the stress is applied, and when the stress is removed, it came back in the original position. This is never the case with the soil. So the plastic equilibrium become very important in the case of geotechnical engineer. So designing the retaining wall and retention schemes, analyzing the seed pile, dressings and cuts in the soil, introduction or to the different types of seed piles, anchored and non-anchored. So over there, the different applications are there. Apart from that, when you talk about the retaining wall and earth pressure coefficient, so two of the most important factors we are dealing in. So one is the active earth pressure, another is the passive earth pressure. Now you must have confusion about the active. You might have heard about these terms. So the active earth pressure is represented as K, and this value is 1 minus sine phi by 1 plus sine phi. So you are aware about this is 1 minus sine phi by 1 plus sine phi. Okay. Similarly, Kp is 1 by K. Kp is 1 by K. Now, the earth pressure, active and passive earth pressure coefficient we have talked about, and you have understood these terms in a very well manner. But you must have aware about the some of the terms. What terms I am talking about? I am talking about the terms like I am talking about the terms like the earth pressure at rest condition. During the earth pressure, and when the earth pressure is at rest, there is no active and no passive pressure is acting. In those situations also there is a some value of coefficient of earth pressure. So that value is represented as K naught, and that is nothing but 1 minus sine phi. Okay, or and this is also mu by 1 minus mu. This is I am stating over here because when we going to solve the problem, if some problem is there on the earth pressure at rest condition, so you must be aware about those aspects during our discussion. You doesn't feel blank, you doesn't feel null or void during those discussion. Okay. This is a very basic thing. Okay, over there again, the formula is written as well. The Kp is 1 plus sin phi by 1 minus sin phi, which I haven't written over there. I just written the aspects. Similarly, the K is 1 minus sin phi by 1 plus sin phi. So we can also derive this term. Basically, we have derived in some way or the other. Then we are able to get this value, and we have stated this value. Okay, so I will go ahead and stabilizing and destabilizing forces. So understanding the forces that stabilize and destabilize soil. Okay, I have talked about the active and passive state, the coefficient of active earth pressure and passive earth pressure, but I haven't explained. So you must need to have understanding of those terms as well, because if you understood the value and you are solving the problem, there is no benefit of that, because what are the basics behind that, why we are telling this is active, why we are telling this is passive, is also need to be understood by you. So first of all I will draw that for you, and afterwards what is the when we talk about the active, when we talk about active, the suppose take an example of the retaining wall. When we talk take an example of retaining wall, and soil is filled behind that, when the wall is moving toward the soil, when wall is moving, suppose this is a wall, and over here there is a soil, this is soil. Okay, when wall is moving in this direction, this is my wall. So when this wall in this direction, this is said to be active, active state. Similarly, if in a similar cases, if this is a wall and again this is a soil, this is soil. When we talk about wall, this is a retaining wall in a real sense. So when the wall move toward the soil, when the wall move away from soil. This is the passive state. Okay. So there are the two aspects we are talking about. One aspect is when wall is moving toward the soil, that state is said to be active state of soil. And when we wall is move away from the soil, that state is said to be passive state of soil. In both cases, in one cases the horizontal stress is maximum, in one cases the passive stress is maximum. When the wall is moved toward the soil, the stress acting in this direction is very strong, very strong, and this lead to the this lead to the reduction in strength. This lead to the reduction in this lead to the another state of stress in the wall and the soil interface. Similarly, if the wall is moved away from the soil, in that cases the horizontal stresses are released. Horizontal stresses are released, but the vertical stresses remain same. So the primary stress become this direction. We are going to solve the problem. We are going to taking the concepts in which the active and passive earth pressure takes place on the different types of soils, and how we are able to calculate the stress at specific sections. How we are able to take the encounter the aspects of active and passive earth pressure in a real sense in a field scenario. We will going to take care of those concepts as well in a subsequent sections which is coming ahead. Okay. Now, stabilizing and destabilizing. When we talk about stabilizing and destabilizing the forces, okay, on this slide only we have go in a backward direction and understand the concepts of the active and passive earth pressure. So, understanding the forces that stabilize and destabilize soil is very much important. So the stabilizing force in the shear strength is very much important. In the strength, shear strength is not there, so the soil is never stable. It will go draw down instantly. Similarly, when we talk about the destabilizing forces, the gravity, rain, snow, earthquake, and human interventions are the terms which will lead in the destabilizing the soil, which is present over there in a specific condition. Now, when we talk about the ground stabilization and the shear strength enhancement, the forcing focusing on the scenario with the very low strength like the marine deposits highlight the art of geotechnics enhancing stabilizing forces against the odds, and the ground stabilization, soil improvement, and the path to the soil reinforcement is some of the aspects. Okay, I will go ahead with the term in which we inside the okay. There is a term related to the Poisson ratio. When we talk about the active and passive earth pressure, I have stated the earth pressure in rest condition in the term of Poisson ratio. Over there, I have written as K naught equal to mu by 1 minus mu. Okay, so that term where it's come from? It's from the Poisson ratio terms only, and when we talk about the coefficient of earth pressure like the active earth pressure coefficient or the passive earth pressure coefficient like k and kp, so that is nothing but the ratio of stress in the horizontal direction to the stress in the vertical direction, where k naught is a function of over consolidation ratio, relative density, soil types, water content, and on the basis of that only we are stating the different types of property for the soil. Okay, I think so. This thing is very much clear. Okay, now the visual representations of the plastic equilibrium. We have started talking about the plastic equilibrium, so the visual representation must be understood in a true sense by us. So the visualization of the plastic equilibrium on a tau sigma plane is also one of the important aspects. So we have understood this term with the help of the Mohr Coulomb envelope, because when we are drawing the Mohr Coulomb envelope, in one way or the other, we are trying to achieve the plastic state from, because in geotechnical engineering the elastic state is elastic state condition is not achieved at any point of time, because we already know the value of elasticity, the value of elasticity has no significance when we talk about the geotechnical engineering. Have you ever imagined like the soil, the any type of soil has some elasticity? Like if we apply the stress over there, it will, and when we remove the stress, it will regain the same strength what it has. So this is the basically of no discussion point talking about the elastic aspect. So the plastic aspect is only important things. Okay, so as I have stated about the active and passive earth pressure, the pushing against the retaining wall. When the wall is moving toward the soil, when wall is moving toward the soil, that state is the active state, and in that case, the stress takes place in that case. And similarly, if the soil is moving away, so that is the passive state. And in a similar manner, we will able to state the difference between the active and passive state. Now I will recap these sections. Afterward, I will move to the next section. So time also going out. We are running out of time at some aspects. So we will go a little faster to complete the today's session, complete the entire content which I have prepared for this session. Okay. So the through this section we have understood the gap between the elastic and plastic stresses, and we also understood the significance of the plastic equilibrium in soil mechanics. Apart from that, we able to tackle the practical geotechnical challenges through the deep understanding of the plastic equilibrium. As we are concluding this section, not session, we must need to be remembered that the stability and the instability in soil system is in and fascinate on, and the knowledge of the plastic equilibrium, we are ready to venture into the real world geotechnical engineering where the principles we are discussed will guiding the shaping the secure environment for our understanding. Now we have understand the value of the shear strength earlier as well. Now talk about the definition. When we talk about the plastic equilibrium definition, so you must be aware about the fact like the state of stress at which the soil is on the verge of failure, because when the soil just going to fail is the case when is the case when we are concerned about those aspects. And when we talk about the importance, the understanding the cases of stress developed and the application in engineering is also one of the important aspects of when we are talking about the importance. Now the third is the focus on applications. So the retaining walls, slopes analysis, bearing capacity assessment are the some of the more aspects. Okay, moving ahead, when we talk about the application of plastic equilibrium, retaining wall and seat pile, retention schemes, designing of retaining wall, introduction to the seat piles and bracing. Over there, the active and passive earth pressure concepts also came into account, and the analysis of cut circulation into different types of soils are the sections over the plastic equilibrium application takes place. Because when anytime we are studying about the seat pile wall as well, or the any retaining wall, because you must go from one place to other, you have seen beside the road the very large retaining walls are there. So on those retaining walls the plastic equilibrium application is applied. Those retaining wall takes the aspects of the active and passive earth pressure. So those understanding need to be very much clear for the designing aspects of the retaining wall. Some more applications in a slope stability analysis. In over there also the objective is the preventing the instability and the failure. Analysis of the finite and the infinite slopes takes place is the application of the plastic equilibrium. Apart from that, emphasis on slope stability analysis method is also the one of the aspects. Apart from that, when we talk about the bearing capacity of soil, the relevance of the bearing capacity in foundation design, board application to the both soil and rocks, each one more aspects. Apart from that, linking failure causes to the stabilization and destabilizing forces, each one more aspects we need to be understood. Now, defining the plastic equilibrium, the clarification of the term the plastic equilibrium, introducing the concept of plasticity in and the plastic deformation is one more aspects that we need to be take care of. Now we will move to the passive and active earth pressure in a real sense. When we talk about the passive and active earth pressure in a real sense, the passive earth pressure condition leading to the passive state. In this condition, the relation to the shear strength, the state of stress where the plane converges and the inclination of the failure plane is 45 plus 5 by 2. While when we talk about the active state pressure, the condition lead to the active state, the state of stress where the plane diverges and the inclination of failure is 45 plus 5 by 45 plus 5 by 2. Similarly, when we talk about the passive state, over there the inclination is 45 minus 5 by 2. So those aspects need to be understood, aspects need to be stated for the practical example, real example, and understanding those aspects in a convergent. Okay. So the role of gravitational forces. Gravitational forces also play the most important role, because when we talk about the stresses, we take the density multiplied by depth, and we are stating the stresses. We taking the density of the soil and multiplying the value of height. So we are taking the gravitational impact only, because in a soil sections at a certain depth, the value of the stress at that section in a soil due to soil is also due to the value of the gravitational aspects only. Now, we also have understood the geology and the tectonic movements influences the stress distributions, and linking the plastic equilibrium to the natural process. Now, the geotechnical engineering application, when we talk about the monuments, structure and walls are already there, and observing the soil induced effects, understanding the tectonic motions and the geological forces, engineering implications of the plastic equilibrium in design. When we recap this section, the plastic equilibrium as a fundamental concept in the geotechnical engineering and the application in the designing stable structure and prevailing failures, acknowledge the role of the gravity and geology in shaping the soil behavior and the state of stresses is some of the most important aspects. Okay. Now the mechanism of the development of the plastic equilibrium. Okay, we have talked about the plastic equilibrium, but how it get developed is also one of the aspects that we need to understood. So when we recap the previous section or the lecture of the plastic equilibrium in a soil, the focus on the local mechanism leading to the plastic equilibrium in soil and the different scenario has been taken understood and taken into the account. When we talk about the different scenario in the plastic equilibrium, a different scenario like we have studied the on a slope, on a retaining wall, on a railway sections, the railway sections, when we increase the height of the sections with the help of some walls or some the braces. So those sections are, we are talking about the different conditions. Now the sliding failure, the active earth pressure, introducing the scenario of the sliding failure, the demonstrating a box on a horizontal surface filled with soil. The definition of plastic equilibrium in this context we already stated, and the explanation of the active earth pressure and its key characteristics is the another aspect. Now talk about the Rankine earth pressure theory. We already know on the Rankine, there is a Rankine active earth pressure theory, and another is the basically one is the Rankine theory, and another is one more theory there in which we apply in a clay soil. The theory name is okay. I will state you. I doesn't state able to recall at this point of time, but I will state you the another theory is also there, which is mostly used in a clay soil. Okay. So we will move ahead. Basically, there is a concept like k gamma z minus 2c root k. The concept of minus 2c root k, which is applicable in the cohesive soil, came from that concept only. And when we solve the problem during the next class, we are going to solve the 2 to 3 problems in this class as well. But when we go to solve the problem during the subsequent classes, you come across the problem in which the cohesion is there, the kp value gets changing, the value of phi gets changing from one phase to another phase. So the active earth pressure also gets changing from one phase to another phase. So the different aspects came across when we draw the stress. diagrams for the soil, you will find that the stress variation takes place at different sections. Due to the variation of K or Kp, whatever you are calculating, active or passive earth pressure, the different aspects also came into our sight. So those aspects are very much promising and very much understanding. We develop our understanding in one direction. Okay. So the active work pressure, for the active work pressure, we have to calculate the vertical stresses. And vertical stresses is nothing but gamma ray. But when we talk about the vertical stresses, we are calculating the effective vertical stresses. And we already know the horizontal stresses by vertical stresses each K. So when we are calculating in cohesionless soil, that is not, so the horizontal stress is nothing but K into vertical stresses. Over there also you have to calculate the stresses at certain section, and sometimes you have to calculate the stresses at sometimes you have to calculate the stress at some section, but some other time you have to calculate total stresses which develop at certain sections. You have to find the positions, the position at which these stresses will act, resultant stresses will act. So those things need to be understood, and those things need to be analyzed in a better manner. Okay. Okay. So the, and after that we will derive the, we can derive the interrelation that's between sigma h and sigma v, but we are not going to do this thing today in this class, but we can derive that as well. Okay. Now the equations and derivations, there is a concept of inclined backfill as well. There is a question also I have put over there. So in a inclined backfill, there is interrelation is there. I will state at that point of time only, but I can state right now as well because I have remember those concept: cos beta minus root under cos square beta minus cos square phi by cos beta plus root under cos square beta plus cos phi is the value of the coefficient of active earth pressure at the inclined backfill. When we talk about the inclined backfill, the inclination of soil is at angle beta from the horizontal, because in normal cases the soil is there aside of the wall, but when we talk about the inclined backfill, the backfill is also at certain inclination from the horizontal, it is not in the horizontal direction. So those aspects is very much clear. I think so, not very much clear at this point of time, but when we solve the problem, when we I state with the help of diagrams, so you will able to understand in a very good manner. Okay. Now, the passive earth pressure already stated it, the angle of inclination of slip is 45 minus 5 by 2, and the formation of passive earth pressure takes place. The explanation of the scenario of the wall movement inside the backfill is also stated in a over there, and the moment about the hinge rotation and deflections, the introduction of the concepts of the hinge characteristics and the mechanism of wall rotation about the hinge point, deflection and the strain association with rotation is also need to be stated. Apart from that, the wedge formation. Okay, the wedge theory is also one of the important theory which I will take during the next class, because this class we doesn't have that much time to discuss everything in a so much detailed manner, but in the next class we are going to discuss those aspects in a very well manner. Okay. Okay, so now I will recap this section, and afterward I will solve. I have to solve the three problems, at least three problems. So I need at least 5 to 7 minute time for those problems. So I will move over there after this. So importance of understanding, when we recap this section, importance of understanding the local mechanism and plastic equilibrium, realization that the engineer projects must account for these mechanism, and revealing the future. When we go for the future lectures, we explore the more complex scenario and more complex problem for the understanding. So with this, I will close the theory session for today, but I will take the some of the questions. Afterward, we will end the today's sessions. Okay, so the very simple problems are there. You have to state the solution. I will state the solution for you, but you must need to understand these aspects, and afterward, I will close the today's session. Okay, so the first problem is like The earth pressure for design of a bridge abutment is taken as there are three options are there, that is active thrust, passive thrust, and four options are there: active thrust, passive thrust, and thrust in the rest condition, and another is none of these. So you have to state the solution for this problem. When we are concerned about the solution of this problem, we must need to be aware like earth pressure for the design of bridge abutment. When we talk about the bridge abutment, the bridge abutment is the conditions where the soil pressure across it in the rest condition. So there is a thrust is said to be in rest condition. Neither it is a active thrust nor it is a passive thrust, because this is a real life scenario. Real life scenario, when we talk about, we are concerned about the pressure which is acting, because when we talk about the retaining wall, the pressure act toward the soil or away from the soil. On the basis of that, we have stated the active and passive. But when we talked about the aspects like the earth pressure for the design of bridge equipment, over there the thrust is in the rest condition. So this is the solution, and at the rest, the earth pressure exists when the wall earth pressure is rigid, that is when the no movement is occurring in a case of deep basement wall or the U-shaped abutment of the bridge. Okay. Now the next problem is there. The next problem required to be solved, and this is a very simple problem. As I have stated earlier, the coefficient of active earth pressure we need to calculate, but on the inclined backface. So what are the components which is given? I will state to you, and afterward I will show you the solutions as well. So first of all, see, okay. So see, first of all, a vertical wall of 6 meter height. This is given. High above the water table, retains 20% of the soil slopes, and the retained soil has a unit weight of 18 kilonewton. The appropriate shear strength parameter C is 0 and phi C and phi is 40 degree. The coefficient of active earth pressure to be used in estimating the earth pressure. Okay. So over here, you might confuse sometime between the value of phi and beta. But over here, the value of beta is, there is a value of beta is nothing but 20 degree, because it has been clearly written in the first line only. The vertical wall 6 meter high above the water table retains the 20% soil slope. So this value is beta only. Afterward, we know the relation I have stated to you, like the value of cos beta minus root under cos square beta minus cos square phi by cos beta plus root under cos square beta plus cos phi. With that interrelation, you are able to state the solution. And so this is the interrelation, and with this, when we solve, we will get the value of active earth pressure coefficient as 0.25. So one more question arise in our mind. So is this relation is applicable in any case? Yes, it is applicable. See, if you use this interrelation na, and you use the value of beta as 0, then also you will get the value of Ka, which we able to get in normal circumstances. So this thing will be very much clear for you. I think so. Okay, so I will take another problem, and this will be last problem for the day. And with this, we will end our session. And afterward, we will meet on the next Saturday. So, what is the problem? The question is like for the determination of earth pressure Coulomb gauge theory. I have talked about the gauge theory, but I haven't taken in that as account. So, if you are not able to answer, that is well and good. But this is the futuristic thinking. So, I will give the some aspects. So, you there is a thing in your mind. What is the Coulomb gauge theory? So, you must come after reading some points in the next class. So explaining those terms will be interesting for you as well as me at some point of time. Okay. So for the determination of earth pressure, the Coulomb wave theory assumes that Four options are there. The back of the wall is smooth and vertical. The soil is non-homogeneous and anisotropic. So first of all, if you go with the method of elimination, you will say the answer never be, and the answer never be D. Never be B. So this is not the solution. Now the slip surface is circular, the wall is rough, and these are the problems. So the one answer is eliminated. So over there, the back of the wall is smooth and vertical. The Coulomb wave theory doesn't say as well. So this is also not the answer for our problem. The slip surface is circular. I will write the assumptions for you during the next class. So this is also not the answer. So the answer must be the wall surface is rough. I think so. This is much must be clear. So when we go, you see the solution is D only. So, afterwards, we will go with that. So you must be aware about the fact that what we have discussed to, so try to solve some problem with these concepts and these aspects. After solving the problem, you will feel more confident with these concepts. And with this, I will end the today's sessions. And in conclusion, I want to say whatever the concepts we have discussed till today from this class or earlier from this class, the concept of shear strength is already completed. So take the book and solve the problem. So you will get the better idea and you will become better understanding. And at any point of time, any confusion is there, you can state me during the next class. And with this, I will end the today's session. See you in the next session. Okay.